KCC Robotics autonomous model developed in MATLAB Simulink uses a flexible system of PID controllers that are given instructions based on the primary control system with a simple-to-use coordinate grid. These coordinates are turned into a usable vector by a grid-to-vector subsystem, which gets the distance with a hypotenuse, converting it into the degrees of the wheel encoders. Then the converter uses some simple trigonometry to get the clockwise angle of rotation. These targets are sent to the rotation and distance PID controllers. These are activated by the PID switcher, which relays motor commands to the robot and detects when the PID controllers have reached a stable state at zero difference from the target. This will send a reset signal to the motor encoders to be ready for the next target and allows the control system to choose a new target. As you can see, first it rotates and then drives using the mode variable to toggle the PID controllers. Inside the rotation PID controller, it starts by partially correcting an error with the robot angle sensor, then gets the difference and goes through the mode switch, feeding target data to the PID controller. Then, stability at zero is tested and the motor commands are sent off to the PID switcher. Next, the distance PID controller is activated, taking left and right encoder inputs, and just as the rotation PID detects a stable state has been reached, allowing the control system to move on to the next step. Running the simulation, we can see the robot rotating with sensors displayed on the left, yellow being the right encoder, blue being the left encoder, and orange being the angle sensor. As the robot reaches its target angle, the PID switcher changes to drive mode, and the robot goes toward the isolation frame. Upon reaching the target, the control system moves on to the next step, dropping the vaccine. We can see the rotation and distance PID input and output, while they attempt to reach a stable state. As the distance to the target decreases, so does the motor output. This system is nearly perfect except for one major flaw in sensor limitations. Specifically, the angle sensor is hard-coded to not go below 0 or above 180, and instead flips directions, making proper rotation impossible past 180 degrees. The second target is only able to be reached because of the absolute value negative angle target, as you can see by the bounce here.